Okay, so now we're going to move on from blackbody radiation to the photoelectric effect. So just to place this all in context, remember, we're talking about in the late 1900s, or we're going to continue to place it in context. We're talking about the late 1900s when the electron was discovered in 1897, and now is the smallest piece of matter. And then the blackbody radiation was understood empirically for a fair amount of time until Planck came along in 1900, so just 3 years after the discovery of the electron, and was able to describe blackbody radiation as something which occurs through the quantization of energy in a harmonic oscillator. And while Planck did not believe that that had any bearing on the actual underlying physics necessarily, it was yet another piece of quantization. And then comes the photoelectric effect. The photoelectric effect was first discovered by Hertz in 1887. It was observed. It was observed when he was illuminating metal plates with UV light when he was studying radio waves. And Hertz observed that when illuminating these metal plates with UV light, that they would emit sparks. And it was 1901, 14 years later, that's 1902, German scientist Leonard was able to show that the emission from these plates that were being illuminated by light were actually these electrons that were just recently, 5 years earlier, discovered by J.J. Thomson. So all these discoveries are really tied together, and also remember that they're tied together also by this simple experimental fact that people are able to now pull vacuums or make good vacuums in glass bulbs and do some of these experiments under low pressures and be able to more easily study the electricity or the electrical phenomena that's going on, that's not going through a wire or something like that, that's just in the air. It's kind of hard to study when you got the atmosphere around, but when you can evacuate a glass cylinder, then there's a lot more experiments you can do. So it's all really precipitated, a lot of it, by that. Anyway, okay, photoelectric effect, discovered in 1887 by Hertz. It's understood that it's electrons in 1902 by Leonard, but it's not understood. But the effect, and this is what we're going to talk about, the effect is not understood. What is the photoelectric effect? The photoelectric effect is, as we've already said, is when you illuminate something with light, in particular maybe a metal plate with light, it will emit electrons. That is the photoelectric effect. You say, what's not understood? It's an energy conservation thing. What's not understood is why the energy of the electrons that are being illuminated is what it is. The amount of energy is not understood. Just like the shape of the blackbody curve, the amount of energy being emitted wasn't understood. In this case, it can't be explained. It doesn't make sense. And it was Einstein in 1905 who pulled it together, along with Planck's hypothesis, presumably helped along by Planck's hypothesis, that Einstein was able to show that the photoelectric effect occurs because of these quanta of energy, this packets of energy that you could explain light as being, whereas in Planck's case it was harmonic oscillators. In Einstein's case with the photoelectric effect, it's about light. And Einstein pulls it together and shows that the photoelectric effect is due to quantization of energy. And Einstein got the Nobel Prize for that in 1921. So it was a pretty big discovery, and it really was the real start of quantum mechanics. Planck first helped inform Einstein, but then Einstein, in a larger sense, right? Planck didn't win a Nobel Prize, maybe he deserved one, but in a larger sense, Einstein understood this as this is the crack in the wall. We're not going to be able to fix that wall anymore. The wall's going to be knocked down, and we are going to put up a new one with a new science of quantum mechanics. So let's look at the photoelectric effect, what was and wasn't understood, and what requires quantum mechanics. Now, remember, the photoelectric effect, I said what it was. It's the reason why solar panels work. Solar panels work because you're shining light on a material that is then emitting electrons. And that's exactly why solar panels work.